All right, in this video, what I want to do is cover 3 basic, easy literal equations for you to solve. So if you just need a quick little review of remembering what exactly was literal equations, how do we solve them, or this is your first time actually trying to attempt solving literal equations, then this is why this video was designed right for you. So let's go through the idea of solving these 3 examples of literal equations. So what I did is I have an equation, and then I have a nice little semicolon with the variable that we are going to be solving for. So the first example is d equals rt, and we want to solve for r. Now remember, ladies and gentlemen, when we're trying to solve equations, we're trying to isolate that equation, right? So when I say r, what I need at the end is r equals. So what is r going to equal? I need to get r by itself. So what we need to be able to do is identify what operations are being applied to my r. Now this says d equals r times t. And sometimes you're saying, well, r is being multiplied, or r times t, right? So what operation is being applied to r? T times r times t. Well, it's multiplication, right? D equals r times t is the same thing as d equals t times r, right? It's cumulative. So it can go either direction, but we need to understand is to undo the multiplication of r, we need to apply our inverse operation, which is going to be division, right? And so therefore, to undo multiplication, we are going to divide by t. But remember, properties of equality, we need to make sure we divide by t on both sides. Now t divided by t is going to equal to a 1. 1 times r is just going to be an r. So therefore, d divided by t, I don't know what that is, and I know that's why a lot of students have trouble with literal equations, because we have so many variables. You're not actually getting a integer answer, you're going to have more than one variable. So r is going to equal d over t, but I can use the reflexive property to say r equals a d over t. And now we have isolated the r and solved for it. It was pretty basic, right? Just one step. Just undo what's happening. Now, this next example, we have some other mistakes that students usually come up with. So in this problem, I have some numbers. So students are usually a little bit more familiar with this. They kind of like that. Ah, man, I kind of want numbers back again. Forget about the variables. So I have 4x minus 3y equals 9, and we want to solve for y, right? Very similar for linear equations to be able to graph and stuff like that. So let's go through our operations. We have a multiplication by 3, right? We can see that. And then this is where usually students get tricked up. They see the negative, right? So sometimes they're like, well, there has to be like subtraction by 4x, like it's 4x minus 3y. But we're not really actually subtracting, because again, ladies and gentlemen, sometimes it's helpful to rearrange things to kind of see what they are. Now, in this case, subtraction is not cumulative like it is for multiplication, but I can rewrite this. So therefore, the variable that I'm trying to solve for is in front of the 4x. So this is a negative 3y. But this is a positive 4x, right? There's no negative in front of this 4, so that's a plus a 4x equals 9. Okay, now let's go and identify what is happening to my y. And sometimes I tell my students, when you want to solve for the y, sometimes you can put a little box around it and just pin it. And what we want to do is just understand what is being applied. So we are multiplying by y by negative 3, and then we're adding by a 4x, right? So now we need to undo what's happening. So we need to undo in multiplication, we need to undo addition, but we need to follow the reverse order of operations. Remember, when you're evaluating, you follow the order of operations. When you're solving, you want to do the reverse order of operations, meaning you always want to undo your exponents, then undo your parentheses, undo multiplication and division, undo division. I think I messed this. Yeah, undo your addition and subtraction first. Man, I messed that up horribly. Undo addition and subtraction first, undo multiplication and division, then exponents, then parentheses. So here I have no parentheses and exponents, so I'm just going to be undoing my addition first. Okay, now again, I cannot subtract a 9 minus a 4x. Don't try to do the 9 minus 4 from there. They're not like terms, right? For you to be able to subtract that 9 minus 4, they both either have to be integers or they both have to have an x with them as far as their terms. These are not like terms, so do not try to combine these. Now, again, so now I undid my addition, so now I just need to make sure that I undo my multiplication. So instead of multiplying by negative 3, to undo that, I need to divide by negative 3. Again, notice how when I'm dividing on both sides, I'm putting this division bar over both of these, right? Because I have to divide this negative 3 into both of these terms. And a lot of times students don't want to do that with the 4 because they're like, oh, 3 doesn't divide into the 4, so let's just not do it. Well, no, ladies and gentlemen, it's still being divided by 3, so we have to represent that. So 9 divided by negative 3 is a negative 3. Negative 4 divided by negative 3 is just going to be a positive 4/3 x. And then typically, this is still correct, but typically in mathematics, we like to have the variable in front of the constant. So therefore, y is going to equal a 4/3 x minus 3. Okay, so on this last example, you can see that we have an 8 in the denominator, and we need to solve for it. Now, I know we can just go ahead and apply the cross product, but I think just as a math teacher, I just have so many fundamental problems with the cross product of students not understanding it and applying it incorrectly. So I'm just gonna follow suit with what I did for the rest of this video and just use our inverse operations, okay? Or at least in this problem, you can see like what operations is being applied to A. It's kind of confusing, right? So I think in the initial point, we can't really use our inverse operations, but we can at least understand that A is in the denominator. I need to get A off of the denominator. The easiest way to get something off the denominator is to have it divide into something it divides into. So for instance, like if I had like 8 divided by 4, I don't really need 4 into the denominator, right? Because 4 divides into 8 2 times. So what should I multiply x over a by so a will divide into it? What's the smallest term I can multiply by x over a so a divides into it? Well, that, ladies and gentlemen, is going to be a. Now again, remember, whatever you do on one side, you have to do on the other side, okay? So now I can say those divide out. So x is going to equal a y times a divided by b. Now again, we're trying to solve for a, right? Not x. So it looks like, hey, it looks good, but we're not trying to solve for a. Now I can rewrite this, right? Now the difference here is y times a divided by b. We don't have the distorted property here. B is not divided into the y and divided by the a. So what I can do is I can rearrange this so it looks like this. So x is going to equal to a y over b times a. Now again, what do I need to do? All I need to do is undo what's happening to my a. My a is being multiplied by y over b. So the easiest thing to do would just be to divide by a y over b. However, a lot of students don't like dividing by fractions, right? It's kind of confusing. How do you divide by fractions? I forget what's the rule. So remember, or hopefully you can remember this, dividing by a fraction is the same thing as multiplying by its reciprocal. And now you have solved for a.